Okay, good afternoon everyone. So today we are going to talk on the security aspects, and today's theme is how to use AI in security. But today I'm going to talk particularly about AI in cybersecurity. My goal is to give you exposure to how to use or at least what's the role of AI in cybersecurity. Rather than, I'm not going to talk about any particular application here, but I'm going to rather talk about application of AI in cybersecurity. Okay, so let's get started. So how many of you know CERTIN? CERTIN. Can you raise your hands? Only two I see, or three. Okay, what is CERTIN?
So basically, it's a government agency, as if we can call it. So it basically scans applications and operating systems for any vulnerabilities, and basically it finds those vulnerabilities and reports to the.
What's your understanding?
So CERT is like almost like a sort of a cyber agency with different areas.
Okay, both of you are partly right, partly not correct. CERT stands for Computer Emergency Response Team. Okay, IN stands for India. Like every country has a CERT team. Okay, you will see a CERT, US and all. So the mandate of the CERT is to make us aware of the cyber threats. Like as he said, they are not going to scan any operating systems and all. Somebody will do. And when it becomes, as soon as it becomes a public knowledge, or it is known, they will immediately send alerts, or put it in their web page that, okay, some threat, this pages has been detected to be vulnerable. And you might, I don't know if you people receive some SMS says that don't share your OTPs, don't share your passwords and all, right? I mean, these are the kind of adversaries also they kind of keep sending so that they keep us cyber aware. So they keep reporting what kind of activities they are doing about this cyber threat. So wherever the phishing attack happens, they keep track of it. Like if some organizations are subjected to phishing attacks and they get to know about this, they will report. And if there are some unauthorized network scanning probing happens, they will report. And if some applications are known to have some vulnerabilities, they will also report them. Okay, some viruses, malicious codes, anything they become aware of, they will report them. And also the website defacements. You might have been seeing that, at least heard in the newspapers that some websites have been hijacked. And those people with some arbitrary message after hijacking them. So those are called website defacements. They report all those things. Okay, so CERT mandate is to make sure that our cyber infrastructure is secure and also make us aware of what kind of threats we are exposed when you are in the cyber world. Okay, now cyber attacks are not so uncommon now. They are become kind of routine things. We will hear about them almost, I mean, maybe once in a week at least. So how many of you heard about the recent AIMS attack? So what kind of attack it was? So what is ransomware attack? Locks?
They just said denial of service.
They want a ransom. They encrypt our apps and ask for the ransom to be reflected.
Yeah. So ransomware, there are different flavors, but one flavor is if once they get into system, maybe they will encrypt all your data. Now you don't have access to your own data, right? Because of the data is encrypted, your applications will not run, right? Like where will application are going to fetch data, and that's it. Like all your machines applications become useless to you. So that is one kind of attacks. And also, how many of you have heard about the cyber attacks that is going on between Ukraine and Russia? Okay. So now cyberspace is considered as one of the war fronts, right? It's not just like what's going to happen on the battlefield, but also what happens in the cyberspace. So in the war, cyber attack are the first stage. That is what it's going to cripple your enemy's infrastructure. So a lot of cyber attacks has been also reported there. So fine, cyber attack is not just going to happen during the war or not. Like any malicious user can do cyber attacks, and with the malintention that just to cripple you. Okay, like many people do some malicious things, and you might have heard like people lost money. Somehow money got transferred from their accounts. Okay, so all this are possible when you are internet and we are connected, and if there is any issues in our applications, people can get into our accounts, and without our knowledge things can happen. So cyber loss is actually has a lot of economic consequences, not only as an individual, even for the organizations. Like suppose if for example in the AIMS case, somebody come and encrypted all the data, then all their applications are not running, then AIMS is losing money because of that. And similarly, if some company's data is encrypted, then their business can't run. That is like a huge economical impact. Okay, so it is not only national security threat, it has economic consequences and all. So it is very important that all of should be aware of the threats on the cyber front. So here I have just listed some of the attacks that have been recently reported. Maybe it is just like a data of last year. So I'm sure many of the companies you know here. Razorpay is again a mobile payment app portal. Amazon, Flipkart, Airtel, Jio, everybody knows. Oil India, Tech Mahindra, Mobivic, Air India, Domino's. I mean, all these are supposed to be one of the high-tech companies, but even they are been subjected to cyber attacks. Just then think of all the small companies which are not so cyber savvy. Okay, and as I said, like cyber attacks are now become a kind of routine thing. Every month things get reported. I think this is again a data from last year. I have listed some of the very widely published or discussed attacks. Okay, when I say very published, like they came in media and a lot of discussion happened around them. In fact, these have come, like many attacks just go unreported. Right, say somebody does a ransom attack, and that company is just like feels that okay, I will give that money to that guy, and they give, and then that won't get reported because they just, because if somebody reporting that attack is happened on my network, it's an embarrassment for them, right? So people even don't want to report that. Like if some company says that okay, cyber attack has happened on my network and some data, users data is stolen, then users will lose faith in that company, right? Like it has so happened that in many times, I don't know which one of these projects, in the cyber attacks, people's credit card details were stolen, or where their health records were stolen and put it open in the public domain. If you feel that your healthcare record or your mobile number is stolen and put it on your on the public domain, you are not comfortable with that, right? So whenever such attack happen, people even don't want to report them. They just want to separate. But some of them came to highlight. Okay, in the December and January, there was one very common attack called Log4j. How many of you heard about Log4j attack? What was it about? What library? Okay, it was related to Apache, right? It was used to log, I mean it was like a kind of logging activity where you can ask for certain command that get executed and you get a reverse shell. So this was a common thing. It became a, like in December, January, it was kind of a 0-day attack, but once it was known, people quickly patched it up. But the point here is these kind of attacks keep coming. It's not that some attacks came and nothing is going to come. Even though you have patched, however smartly you have built your application, other side is also smarter. So they may also, attackers can also get smarter. Some attacks will keep on coming. So that is why it is important for us to defend ourselves against the cyber attacks. Okay. Now cyber attack is not just about me. It's about my dependencies as well. Right? You are an organization here. You may depend on many third-party solutions. Okay, for example, let's say you are in a hospital, let's say. Somebody else may be managing your all the data. Somebody may be managing your servers. Okay, so it may happen, and if the guy who is managing your data has some issues in his softwares, that the softwares he has provided you to manage your data, then you are also exposed. And these are attacks called supply chain attacks here. If in your links, okay, before that, like when we build a software, there are so many dependencies we'll write. Maybe we'll use somebody's GitHub repository, somebody's APIs and all, and maybe sometimes we use a lot of third-party tools just to ease our development cycle, because everything you don't want to write from scratch. Okay? So when you do that, if somebody else has vulnerability, then you are also exposed because you are using their services. Okay, then these are called supply chain attacks. If any link in your dependency is weak, you are also exposed. So you need to be completely monitoring and defending your entire system, and also monitoring about others' vulnerability. Like if you are dependent on somebody else and somebody else is vulnerable, not only about you, you need to also keep a track of how that guy is doing. If that guy is vulnerable, you need to also either isolate this from his service or make sure that that guy provides a necessary patch for you. And often attackers, because of this, they always look for the weakest link in my system. Okay? And if this weakest link is exposed, then the entire system is exposed. Okay, here are some things, I don't know, I mean you people can read out this. There are some certain applications or the entire system that got exploited because of some weak links. Okay, now the question is, okay, fine. We know we will be subjected to attacks that could coming through as a malwares, right? No, but what is the challenge in detecting them, right? Like why it's not easy to detect malwares? Yeah, this malware is not like it will come with the flag that I'm a malware, right? This can be very stealthy, and even they deliberately try to hide. It's not that they just want to come in, they want to obfuscate or hide or do whatever possible so that they go undetected. So we already see there are solutions for this, right? Antivirus, everybody, we all install antivirus, and if not, we get an alert that okay, antivirus is not there, please install. Or I don't know, all of your institutes may be also sending, like make sure that your machines are all updated with the latest antivirus so that it's not exposed. But with the changing behavior of the malwares, it's not like easy for antivirus to detect the malwares. So how does antivirus works? Anybody have any idea? I'm talking about the classical traditional antiviruses.
So as a preliminary test, they will check for hashes, then they'll go for string matching, dividing analysis, and they could also go for full bytecode. Full bytecode scanning, but again, that will take a lot of CPU. They could even look for specific compilers and with signatures. So unless someone writes assembly by hand, the malware will be detected more easily.
So the basic underlying is they kind of do some signature, they look for certain signatures. Like the classical antivirus always look for some static signature. If that signature matches, they will say this is malicious. But the same malware, if you just reorganize and compile and send, maybe the signature will change. The classical antivirus will fail to detect it. So to kind of improve, they have also have this static analysis. But malwares can even avoid this static analysis. They can do a lot of obfuscations. Okay? And even if you want to dynamic analysis, like for example, if you put your malware in a sandbox and in an isolated environment and want to run it and see its behavior, the malwares can be smart there. Like when they see that you are in an isolated environment, they can detect it and they don't do anything malicious. So when you run them in a sandbox, they behave differently. And when you run in a regular environment, they may show their true colors. Okay? And also with as our softwares are getting complex and complex, so many lines of code, so many functions, so many subroutines and all, I mean, a piece of bad code can hide anywhere deep inside, which may go undetected. Okay? And also in the morning, Professor Virendra talked about also adversarial training, right? Maybe they also know how to defeat certain security tools. And overall, above, they may appear very genuine, but when time triggers, they may show their true colors. Because of all this, detection using the classical methods like just analyzing them either through signatures or static analysis or dynamic analysis or doing a very systematic code review and all may not help in detecting a malicious behavior. So we need to go something beyond this. So what's the way forward there?
But how will the malware know it's being run inside a sandbox?
So let's say usually when you run a sandbox, right, you create a virtual machine, right, so that it is isolated. Malware can detect whether it is running in a virtual machine or in a host machine. If it is a virtual machine, it will just shut up. Yeah? And it can even know if it is running in a container environment, like that. And also it can see that when you are running, have you enabled all your security tools? Like if you are running in Windows and you have enabled the Windows Defender, it may don't do its normal activity. So to detect all this malwares, one thing we need to do is we need to have a very good visibility of the network. What I mean by visibility? What kind of activities all my applications are doing? Okay? Like what is the process that is being created? What process is going to create which child parent? If I know child parent, who are its parents? Right? And what file is being created by which process? What file is being written? Which files is being deleted? Which memory block is read? If you can get all this information, maybe we can do something more by doing something called behavioral aspects, which I will come to in a minute. See, malware is a malware, right? It has to be different somewhere from our normal applications. It has to be somewhere different, otherwise it's a regular application. So behaviorally, it has to differ at some point. To identify that behavior, what we need is a very good visibility of all the activities that it is doing on our machines. Okay? So if you want to detect a malware, the way we have to look at the things is we need to have a very good visibility of all the activities happening in my network and also have some way to understand all the behavioral aspects that are originating in my network, which I am observing through the visibility aspects. Okay. How many of you heard about APTs? So any particular APT attack you know?
Sunburst attack.
What it did?
So Sunburst it was a supply chain attack that affected Orion's business services, where they injected a payload in the Orion DLL file, and then because Orion is a trusted vendor.
So this is Iran centrifuge you're talking about, right?
Yes.
Okay. So fine. So as the name indicate, advanced persistent threat. So these threats are very persistent. Okay. They are often called low and slow. Their goal is not to extract money. They will have a very targeted objective, that I want to extract certain information. For example, in the example he gave, US wanted to somehow block Iran's nuclear program, right? Their only objective to stop that. They don't want any money from Iran and all. They just want to slow down their technological advances. So they somehow want to get into their system, understand their system, and identify what all the things I need to do so that I achieve my targeted objective. There could be another class of attacks, that's ransomware. Ransomware are just like, smash and grab. Like, I just want to get, their goal is going to be always economical. So what I mean is financial goals. They want to get into, if they are able to steal something, take that as a hostage and ask for run. So they are going to be very quick. They don't want to persist and linger around your systems. But all these attacks are going to follow a sequence of patterns. Okay. So first, if I have to launch an attack, what should be my first thing? First, the attacker need to get into my system through some compromise part, right? So that is where the initial compromise. Any example of where the initial compromise can happen? What could be my entry point for an attacker into my system?
Application or
Internet, something from internet.
PDF download.
Phishing attacks, right? Phishing attacks. Somebody can just send us a phishing email, and if you just by mistake click it, he may have access to my systems. So phishing is the classical example of your initial compromise. Once he is there, he may want to establish foothold, like maybe he want to now execute his code and whatever the action, maybe he want to run some scripts, or he can start a cron job to get all the details. But like he would be at some, when some user clicks on a phishing link and whatever the application get installed by clicking that phishing link, that application will have the same privilege as that of the user. With that privilege, maybe he may not be able to do all the things. So next thing, he will try to escalate his privilege. Maybe he want to become an admin so that he can do more activities. And after that, once he becomes an admin, maybe he will have access to more resources. Maybe now he can see database, he can see memory and all. So he will do more internal assessment of what your network is. And then he may also want to jump from one machine to another within your network, one server to another. And then from there, he may want to, like once he know that where is the data or the information he want is located, and then start sending that out of your network. That is what that is what called exfiltration. Okay. So whatever this, there is a sequence of steps these attackers will take, and this is where the behavioral aspects come into picture. How these attackers will do this sequence of activities. Okay. Now, you may be asking, okay, why it has to be initial compromise, establish foothold, escalate privilege. Maybe somebody may, of course, everybody needs an initial compromise, and after that, like once he establish foothold, he may don't want to escalate privilege, or maybe he just want to move laterally. Different ways of combinations are there, and each attacker may use his own different way of launching an attack. But to understand like when we want to build a security solution, we will be not looking into like defend ourselves against one particular attack, right? We want to defend ourselves in general about all possible attacks that could potentially arise. So we want to be covering ourselves what all the different possible APTs can come or ransomware attacks can come. So that is why, first of all, it is very important that we systematically put all these possible ways of attacks, and all these steps could be possibly put into certain framework, and that framework often put in the form of tactics, techniques and procedures. Any of you heard TTPs before? Tactics, techniques and procedures? Anyone else? Okay, now there could be various ways of tactics, but there is some kind of standardization as happening, like people have a common agreement about this, and this has been now available in the form of a Maitri attack framework. Those who are interested in cybersecurity, at least they must be knowing this. And here they have put it into all this possible way of launching attacks into several tactics. So first one you will see is initial access, that we said this is the first step that you want to get into your system. And then execution here. Execution is a tactic in which once you get into a system, you try to execute some of the preliminary codes or the cron job you want to do. And next is persistent. So once you are into the system, you need to make sure that you persist there, or your code continues to run. For example, if you run a cron job and that machine is restarted, your cron job may just get killed. It may not restart again. But in that case, you want to also ensure that when the machine is restarted, you persist. How you can do this? You can make sure that your cron job also automatically restarts. Okay? And then you want to do privilege escalations. And also when you do this, you also ensure that you don't get detected. You want to lie low. You want to lie low so that all our antivirus or Windows Defender kind of tools don't detect you. You want to avoid them. And also you want to do credential access. Maybe you want to steal other credentials in the machine so that you can have access to other users. And also you want to discover what all resources are there in my network, or where is that necessary information I want is located. And then you want to move from one machine to another machine so that you can spread, or you want to reach the target server that you would be interested in. So like that, there are different steps will be put under this tactics, and each of them could be achieved in a different possible ways, right? And those are been categorized as techniques. I will not go into that. Those who are interested, you can look into each tactic has certain techniques, and this has been given in this framework. Okay, now with this setup, now we want to ask the question, what's the role of AIML here? Okay, so now first of all we made a little bit structured our understanding of in what ways attack can happen, what sequence of steps attacker can take. Once it's there, maybe now we can ask the question how we can use AIML aspects in it. Or is it that AIML is not relevant to cybersecurity, it's just everybody talks about AIML, I want to use it in cybersecurity. Is it the case? Okay, any thoughts about how AIML can be used in this cybersecurity? Anyone?
Learn the representation.
Huh?
Underlying pattern distribution of how a malicious pattern is behaving in the
How the malicious pattern is.
pattern is behaving inside it.
Mhm.
Or as you can say that there is a huge stream of packets which is getting transition from one device to another device. And in that stream there is malicious packets also. So the distribution,
What do you mean by packet being malicious?
the packet which they transfer between devices.
I mean, it is going to some unauthorized location. That's what you mean? Okay.
Coming from an attacker.
It is coming from an attacker. Okay. So you want to see, but like for that, why you need AIML? Like, I mean, you know, if you know somebody is an attacker, he has to come from some IP address. If you just know that this data is coming from IP address which is not in my list, that is malicious, right?
Yeah, but if we don't know that it is, so let's say if the attacker is inside the system and he is performing that we don't know that IP address is
Okay. So yeah.
You said that malicious program is somewhat different from a genuine process. Malicious process is different from genuine. If we can learn the pattern, like how is it malicious? Because as a human being, we can say that this is acting malicious. Can we learn or take a pattern which can identify those patterns and say that these are the malicious patterns?
So I agree both of you that some pattern. What is that pattern is you are not articulating correctly.
characteristic of particular.
Yeah.
Just to extend this line of thought, I think it's talking about analyzing the content of the packets, because if you're just filtering by IPs, for that we already have firewalls and next generation firewalls and IDS already. That work is already done. But anyone can draft a packet that just looks like a normal TCP packet or a normal UDP packet. It may look like a normal communication between the web server and the client. There will be subtle differences which we as humans may not be able to understand or detect. But if we train a neural network to do the same, then there will be, since it's a computer and it's designed to specifically look for those changes, it will be much faster. And I think that's where.
It is not about speed of computation. It is about running the underlying representation, right? When we talk about it.
Okay. Let's see.
There's the actions performed which are suspicious, so we can train a model which will detect that. If it is like trying to turn off the security feature or something, then we can see the actions, the pattern of the actions it performed.
So if it is just turning on the security aspect, that is like one event for me. Like I know that somebody is turning off security feature. Why I need AIML? Just like if somebody is turning off security feature, I can just say that that's malicious, right?
You can capture the stream of packet using Wireshark.
Yeah.
And then the captured data is captured in PCAP file, right?
Mm-hmm.
So yeah, you can convert that PCAP file into vectorized feature vector value and feature vector mapping, and then using that mapping you can train and learn.
Okay. Let's see.
There would be some unprivileged access, right? I mean, we don't want the user doesn't know and then it's telling me what it is taking some data.
You are barely audible.
So, the malicious process is trying to steal some data which is not which is not intended, right?
Mm-hmm.
So, I mean, can we have some for a rules-based, let's say Windows Defender or some antivirus, that is rule-based, right?
Yeah.
You said like they can change a few pattern and then the whole signature will be changed. But if we train it using some AI which looks into that pattern, which is not just rule-based, but semantically it can figure out like this is what it is trying to do and which is malicious. If we can identify that, it is not just checking a signature. It's going there inside and can identify what.
Okay, so let's see. So what is AIM? Okay, first of all, what is this AIML? So we are always going to treat ML as a subset of AI algorithms. ML is all about learning and AI is about intelligence. Like from the learned patterns, we want to do some intelligent actions. Now, patterns are associated with the behavior, right? Suppose let's say you are a genuine user. There is a certain behavior you do in your network. Maybe you wake up, you do a lot of work on your machine, and after that you don't do anything. Maybe in the lunchtime break also there is not much activity. After that you again do a lot of work, and maybe you also do a lot of work in the night, and early morning you sleep. So there is a pattern. There is a pattern of a regular users. But suppose somebody has hijacked your account. Maybe his behavior need not be the same. Like he will have certain constraint. He has to send out traffic to certain places at some points, right? So then his traffic pattern, your traffic pattern can be potentially different. Okay. Now if I can somehow train an algorithm, like what is your normal pattern, and whenever it sees a pattern which is not this pattern, maybe it can flag it as an abnormal, and that could be a potential first trigger to do further investigations, like what is causing this change in the pattern. That is where do you see the one use case of where AML can come. Other thing, whenever you are accessing a browser, a DNS query goes. DNS get resolved and you are going to connect to that IP address. Now if you look into your organization entire thing, there is a certain pattern in, you can look for certain pattern in the way the DNS queries and resolutions and happens. And when suddenly there is some malicious activity, that pattern may get disturbed. You want to also identify those things by training normal behavior and then trying to identify what is an abnormal behavior. And also, suppose a user is assigned certain credentials, right? He has been assigned only to read certain files and not read and write some certain files. So there is also certain kind of behavior. It's not about particular user, it's about his credential will induce certain behavior in the network. And if there are only this many users with that credentials, maybe network will have certain pattern. If someone else also get added with the same credential, maybe the pattern will change. So you can calibrate or you can try to learn what is a normal behavior and then use that information, additionally other intelligence you are going to gather to see whether it's malicious or not. Okay, and it's not that we have to use AIML here. Lot of things can be rule based, right? If you see that certain DNS query you are sending, somebody has already flagged it as that DNS query is malicious. Then whenever that DNS query is going, you can simply based on a rule you can trigger that is malicious. And also this C2 communications. By the way, C2 communications are always hard to block through your IDS, IPS and firewalls because they dynamically keep changing. And you can't always update your IDS, IPS very fast on the fly. But if you have noticed that your machine is connecting to some IP address which was very new, this IP has not been seen or my machine has not connected to this IPS in the last 1 year. Maybe you can quickly check whether this IP is something flagged as malicious. And by the way, who goes from where you are going to get this malicious thing? There are a lot of open source intelligence on the network. You people have heard about Virus Total, Malware Bazaar, and there are several other things. Open OCI called open source intelligence and all. There you will get all this information about like people dynamically keep watching for what is a malicious domain, what is malicious IP, what are the IPs associated with the command and controls. So you can quickly match. If you see something new, you can simply send an API query whether this IP address is in your database which is flagged as malicious. If so, then you know that some malicious connection is being happening. Then you can backtrace, okay, which application is trying to invoke this connection and who installed it and all, and you can do all the traceback analysis. Okay, but where we want to do this AIML, basically we want them to do automation, right? Like we want them to do in automated fashion without much of our interventions. So that's what we are trying to bring in. Of course, like they are doing a lot of the things which are laborious or manual for them, right? But the issue is, if we allow them to do all the automation, they are also likely to make mistakes or also likely to make false alarms, right? What I mean by false alarm here, like something is flagged as malicious which it is not. False alarm is a bigger threat in such deployment of AIMLs, especially when it comes to cybersecurity. Why is that? Suppose, let's say, you are connected to a network and somehow your AI engine detected that you are malicious and it bypassed you, it isolated you. So then you are out of your network, right? So this should not happen unless it is sure that your machine is indeed having some malicious activity. And how this AIML algorithms are going to detect something is malicious, they also going to be possibly looking into this process, right? We are going to look these behavioral aspects, like what is some application got installed and that application is spreading and its application user has now higher privilege. Maybe it is looking into all these aspects and training, but some of this could be also be like done by a benign user. For example, your admin could have updated your privilege, like admin says, okay, right now you have only read access to this file, but I'm going to give you write access also. So maybe updated your privilege. But for a ML algorithm, it may be just get a flagged, like somebody is escalated his privilege. So it may not know whether your admin escalated your privilege or it is done through some privilege escalation activity. So it may just say that, okay, this is something malicious. So that is why this chaining of the detection, this chaining of the detected techniques across the tactics has to happen when you have to build a sound AIML techniques. So you understand this last point? What I'm saying here is, an attacker can get into system, he may use different techniques under different techniques to do some malicious activities, and some of the techniques that he is going to use could be also used by other benign users. Okay? But just looking into certain tactics, my AI engine should not flag it as a malicious activity, but rather what should do is, it should look for a pattern in them. Okay, this tactic under this tactic under another technique, if this sequence of techniques has happened, maybe that is potentially malicious and my algorithm should generalize those rules. Maybe that if you could do, then it is possibly going to reduce false alarm, or if it is just going to be based on certain techniques, then you are going to see a lot of false alarms. Your system admin will be flooded with alerts. If somebody creates a file, he will get an alert. Or if somebody gets a write permission, then he will get an alert. I mean, these are all genuine activities that are happening in the network, but your system admin will get flooded. So this algorithm should make sure that they connect the dots of all the activities that are happening, and then based on that connection pattern, they should detect whether this should be flagged as malicious or not. And this is the main difference when we like how the AIML algorithms play a role in cybersecurity compared to the other cases. Like for example, I just here when Professor Virendra Singh was talking about whether this is a phishing link or something, right? There it was just a classification. You look at a certain pattern and then you classify. All I need to do is maybe pass on a certain set of features, and then it is going to say whether it is a phishing link or it was some botnet or something. Right? But here it's not the case. You have to look for multiple triggers, connect them, and from that pattern you have to make a conclusion whether it's going to be. So if here the final decision are going to be based on multiple events being triggered. Maybe that is why AI is playing more role here. Like the intelligence part is more. It is not that you could have learned, okay, this technique has happened, this technique has happened, this technique can happen. But this does not necessarily imply this is a malicious. When this technique has happened, what other techniques has happened, that chain of the links is what is going to determine whether it's a malicious or not. Okay? So that is where a lot of intelligence has to go in, and many companies are invested in developing these algorithms for the cybersecurity, and these are going to be complicated. It's not like a simple classification things where you just pass on your CSV file or attributes and the classification is going to happen.
So how do you suggest to model?
Huh?
How do you suggest to model the continual learning of the chain?
We'll come to that. Any question here? So okay, let's pause here. Any questions so far?